the assignment 2 via the presentation, that is task point diagram. And Agilan and Amula Srikanth, you can take your decision. And without much delay, you present your content, and then we will request others from roll number 9 to roll number 18 to deliver online and offline programming. Yes, go ahead, Agilan and Amula Srikanth. Agilan, Amula Srikanth. Is anyone from the second batch? Ananda Krishnan, Anil Kumar, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Anyone?
Hello, sir.
Yes.
Can you hear me, sir? Hello.
Yes. Yes. It is audible.
Okay. So, shall we start, or they have to present?
Ananthakrishnan, you start your presentation, Ananthakrishnan.
Okay. Anurag, share the slides.
Yes.
Yeah, just give me a second.
Yeah.
Is it visible?
Yeah.
Yes. Yes. Yes.
Yeah. Shall I start?
Sure.
So, hello, guys. Me and my team are going to present about offline programming and online programming. I'll be covering the basics of offline programming. You can go to the third slide. Yeah. So, offline programming basically is a robot programming method that does not interfere with the production as the robot program is generated outside the production process on an external PC. The process corresponds to the CNC programming particles, which is the CAD CAM. The robot program created is actually independent from the actual robot cell. The robot program is then uploaded to the real industrial robot for execution. In offline programming, the robot cell is represented through a graphical 3D model in a simulator. Offline programming is used for various ranges of reasons. It is used to save time compared to the conventional, which is the online robot programming. There are many ways in which offline programming saves times and improves the process productivity. It contradicts to the online programming of industrial robots, where the robot teach content is used for programming the robot manually. Next slide. So we're going to see how.
Ananthakrishnan,
Yes, sir.
just a moment, Ananthakrishnan. I think there's a net issue from your side, Ananthakrishnan.
Oh, I don't know. Is my voice breaking or?
Your voice is breaking. Yes, anyway, you try.
Okay. Is it clear now, or still there's an issue?
Go ahead.
Okay, and then I'll explain how this an offline programming work. Most offline programming packages include a simulator for a chosen robot. Only in a few cases the simulator is not required. First, we program the robot in the virtual environment. Then, when we have a debugged program and when it is running smoothly, we then transfer it to the physical robot. The offline programming software achieves this using a post processor, which turns the simulated program into code that the physical robot will easily understand. This method will allow us to remove any problems in the programming quickly and easily using the simulator without affecting the uptime of the physical robot. Next slide. As I said, we need a simulator for offline programming. We are going to see how it works without a simulator. There's only one situation where we would program a robot offline without using a simulator. This would be just if you just program a robot in its native programming language using a text editor computer and then download it directly to the physical robot once the entire program had been written. This situation could technically be called offline programming. We're still doing the programming offline. It's not what we are usually referring to when we talk about offline programming. Usually we mean programming a simulated robot. So that's it from my side. I cover the basics of offline programming. Anil Kumar will then continue. Thank you.
Hello guys, and uh, as I'm
Go ahead, Anil Kumar.
going to yes sir, I'm going to present what I determine if a task can use OLP. The task divided by four parts. The first is software flexibilities and level of expertise and robot compatibilities and robot availabilities. Next slide. And the first one, software flexibilities, is not all offline programming software is just the same. Some packages are supplied by the particular robotic manufacturers, so are locked into those brand and have the varying support for the some tasks. Second, robot compatibilities. Some manufacturers don't provide offline programming software, which is a problem if we rely on the manufacturers. Third, availability of robot model. We need to be sure that our robot model is available for the offline programming software we are using. Fourth, level of expertise. Some traditional type of offline programming, for example, in the automotive industries, involve complex software tools which are not easy to use. Simpler software means less requirement of expertise. Thank you. Next one.
Yeah, hello, I'm Arvind Roshan. So I'll be explaining the generic application. So this offline programming software is used with a variety of robotized process. Like typically this software is used to create the tool parts of the robot and the robot program itself without any need of typing the commands and all. So it's like automatically doing. And this simulation is an essential part to avoid any unnecessary issues or collisions like the joint violation or exceeding speed, acceleration limits and all. So analysis is a good quality. So before the execution of the program is like very important for us. Now the application of this OLP, offline programming. First we have this robot machining. So in the past, like the milling and machining are mainly done only with the CNC machine. But now the robots have started. I mean, those days only robots were also used only for the machine tending things. But nowadays these robots are started to use for all the milling and machining as well. The increased accuracy of the industrial robots and the more intuitive, I mean the easy how the program is, means that we can use the CNC code into a robotic instruction. Next we have pick and place. So this is very common application you can say for the robot. So it is like used almost in every industry. Now this means that we are just taking a cell from one place to another place. It's just like shifting from one place to another place and doing it in like a circular thing. So this is like very easy to program this thing. They claim that less than 15 minutes is taken for a simple pick and place program. Next, we have again a common application, that is robot painting. So it's very easy to do with the offline programming, and it is also like it takes only minutes to just program the pathways of the robot that is painting. And next we have spot welding. So like for the offline programming as a long, I mean, like in the past it was like really hard for the programmer to program the thing for the spot welding. It requires some very skilled programmer and specialized programmer to create the program for the spot welding. But nowadays it's like easy for the any software, I mean the programmer, to make this program for spot welding. Next, my friend will continue.
Good morning, guys. I'm Anjane, and I'll be explaining like the other applications of offline programming. So first is 3D printing. So although it has been around for some time, 3D printing applications have exploded in the past decade. So 3D printing is used in many industries now. And so what offline programming method does is it generates a 3D virtual environment wherein a work environment is defined with respect to a real-time scenario. And offline programming makes this very simple to achieve. You can move on to next slide. Yeah, so it is also used in conveyor picking. So conveyors are used in many industries to like transport objects from one place to another. So it can be used as a mechanism robot or as a graphical program.
Just a minute, Anjanyan Singh. Go back to the past slide.
Okay.
Go back to the past slide.
3D printing.
Anyone?
Sir, your voice is breaking, sir.
Hello.
Yes, wait, just a minute. Anyone knows a little more about 3D printing? How it works? What was the principle? Anyone knows? That additive manufacturing, regarding additive manufacturing, I think now we are learning the unconventional machining process. And concerning your class, who is handling an unconventional machining process? Singh? Is
Hello.
it Anand Babu? Is it Anand Babu?
Which process? Machine drawing.
Unconventional machining.
Yes, sir, Anand Babu.
For both the classes, Anand Babu is handling unconventional. Unconventional.
Yes, yes.
Okay. Concerning this 3D printing, what happened? I think you are all aware about my guide. I have already talked about him. I think so. Dr. Ing Durai Selvam, who is the initiator for the Siemens Center, which was a 200 crore project with a collaboration with the Siemens. A new center is installed in NIT, and with an annexure of Siemens Center, there is a new center called CAMA, that is Center for Advanced Manufacturing and Automation. There are few new machines are going to very soon. They are going to start their work. One among the very fine machine is 3D printing. Usually, the 3D printing is happened with the aid of the polymers and other lightweight material. But in the case of our 3D printer, SAR purchased around 5 crore 3D printer, and that too with a metal 3D printer. Metal, we can even do metal printing with the aid of metal. That was a very fine machine, which was cost around 5.5 crores, and that will work under the laser sintering process, selective laser sintering. in that process that will work. And there is a wide scope for this 3D printing. And you please go ahead with this title, 3D printing or additive manufacturing. There are n number of scopes are available under 3D printing. If it is feasible, go ahead and read an article, try to build. Yes, Singh, you can continue your presentation.
Okay, sir.
Yes, go ahead.
Yeah, next slide, please. Okay, so like third application is automated inspection. So automated inspection can help companies to like improve overall product quality and grow their business while reducing their cost and helping them to become more competitive. So inspection uses machine vision, which has become a popular application. So offline programming of machine vision can never fully replace online programming, but like we need to train the cameras by using real image, and which can like speed up the process. You can move on to the next slide. Okay, so another application is robot drawing. So it is another application where like
Yes, your audio went. Sing. We are unable to get your audio. Ananda Krishna, ask your other friend to continue the session.
Okay, sir.
I think Singh come back. Yes. Singh, Anjanyan Singh. I think you're. Yes, no. You ask others to continue.
Okay. Good morning, sir. I'm Anurag. So I'll continue from here. So another application was robot drawing. So it's in general, you won't really be using a robot for drawing or so. However, for very precise drawings or to convert vector imaging into robot parts, this can be used. So I'll just move on. Integrating an axis. So basically not exactly a task. However, we can do this to increase the robot's workspace. So let's say there's already a huge sphere and then we are adding another sphere alongside that. Or maybe we're taking two robots and adding some degrees of freedom by attaching an external axis with them. So this can be done with offline programming easily because it can be synchronized by code. So I'll move forward. So how LP can save time? So it reduces the startup times. So in general, when do we have non-productive time or downtime? That's usually when the installations happen or calibrations happen, or even perhaps when there's a breakdown or so. In general, when we use a teach pendant, it takes time for us to integrate it into the application. However, with offline programming, let's say our robot is being installed somewhere and we bought it or so. Our program is already ready. We're just waiting for the physical installation to come up and we can immediately start it as soon as that is done. So that's how it does that. Next topic is about the selecting robots fast and swapping them as well. So let's say we have a lot of robots for a particular task. We don't really know what specification will be best, perhaps. So there are a lot of libraries, like the one which is shown here. This is a RoboDK library, I guess. So a library shows us all the robots we have and then which one we can pick. So let's say I'll give you an example for this. So let's say you have a pick and place application and your robot has like some 300 kgs of loaded pellets, it has to take from one conveyor to another conveyor. And let's say you have this one machine of brand A, which has a payload of 400, so you're using it at the moment. So you code in the programming language of the brand A, and then you set it right. However, then there's a change. Now the situation has changed, and instead of moving those 300 kg pallets, which we were doing earlier, we need to move 1-ton pallets. So this time the robot's payload isn't enough. However, the job is the same. So, now let's consider you for this you had another robot of some brand B, whose payload was like more than 1 ton. So let's say 1.2 tons. So this does not mean we'll have to start from scratch and all. We can simply take the same program, convert it pretty easily. There are converting softwares, and then use it for the same. So basically, we're not wasting time programming again with offline programming. So faster programming, basically the code can be reused, as I told earlier, and it's definitely faster than sitting with a teach pendant and showing like trading paths. So I'll move forward. Tweaking programs easily. Again, debugging and updates take a lot of time. Again, reprogramming takes a lot of time. However, since we can reuse it, once again, we can reuse it. So the same functionality does not need to be programmed from scratch for various manufacturers when we are using offline programming. So reduction in quotation time. In general, like this is not very technical. Let's say people ask you how much time will it take you to produce this job, or let's say you get an order, you have to quote some timing. So with software, you can easily determine whether the job is achievable or not. So as Anant Krishnan told in the beginning, he told that it comes with simulation software. So you simply put some random like specified data, a little bit of specified data, and then simulate it and check how long it takes. So you can give a perfect code. Better customization. All right, so robots and CNCs, the difference between them is basically that robots have customizations in them. A CNC can maybe do some 5 processes or machining processes, but basically it's only arm is the machine tool which is stuck at its end. However, with robots, you can change all that. You can maybe use it for loading and unloading. You can use it for machining processes as well. So, and basically you can have some reduced changeover times with the customization you use. So that's how it happens. I have with the PPT, I've linked a document about how consumer businesses are wanting greater customization in the future. So you can look into that once I submit this presentation. And then reduce downtime and cycle time. In the beginning, I talked about the very same thing. So basically, while you code, the program is running, and you can simply just upload your code, which changes it. So, and downtime is basically when the machines aren't operating, and cycle time is the time from the beginning to the end of your process, defined by you and your customer. So basically, when your work is being added, is being acted upon, and apart from it, the delay time which it spends waiting. So you can reduce that using offline programming because low switchover times are there. So all in all, there are low cycle times hence. So next, all right, lead through programming. Ashwin will take this. I'll hand it over to Ashwin there.
Good morning, sir. I'm going to present lead through programming method, and it is one of the online programming methods. During this programming method, the traveling of robots is based on the desired movements, and it is stored in the external controller memory. During playback, robots just follow those recorded steps to do effective work. There are two types of lead through programming: powered lead through programming method, and the second one is manual lead through programming. Next slide. Anurag. Powered lead through programming method. The powered lead through programming method is common programming method in the industries. A teach pendant is incorporated in this method for controlling the motors available in the joints. Teach pendant is the handheld device with switches used to control the robot motions. It is also used to operate the robot wrist and arm through a sequence of points. The playback of an operation is done by recording these points. The control of complex geometric moves is different to perform in
the teach pendant. As a result, this method is good movements, not for continuous movement. Generic applications of power lead through programming. Some of the key applications are spot welding, machine unloading, loading, unloading, and part transfer process, because these applications are such that which requires point-to-point movements of the end effector. So this method can be incorporated in these applications. Manual lead through programming. The end effector robot is taken through its operating cycle by an operator manually, and the movements of each axis are logged automatically at frequent intervals. The joint position sensors, which are normally potentiometer or encoded discs, provide position information as the robot is moved through its cycle. The positional information is sampled periodically and is stored in the computer memory. When played back, the end effector appears to follow a continuous path. Next slide. Generic applications of manual lead through programming. In these applications, continuous movements of end effector is needed. So we can incorporate this method in these applications, like spray painting and arc welding operations are like that. There are some advantages of the lead through programming. It can be easily learned by the shop personals, and no prior knowledge of computer programming is needed for training the robot. And the disadvantages are like it is a online programming method, so robot cannot be used in production while it is being programmed. And the lead through programming is not readily compatible with modern computer based technologies. So yeah, thank you. From here, Anurag will uh, take the session.
Hello, good morning, sir. I'm Shreesh, and I'll be explaining teaching pendant and its advantages and disadvantages. So basically, teaching pendant is a device that controls a robot remotely, and the device allows its controller to work with robot without the need of adhering to a fixed terminal. Next slide. So the most popular method of robot programming is
Yes,
probably the teach pendant.
Yes, just a minute. Go back to the last slide.
Yes, sir.
Yes, it is all the time. It is used to use in a remotely. We can use teach pendant.
Yes, sir.
No, in general. Yes, go ahead. Go ahead. It can be used as remotely, but it might not be all the time.
Okay, sir.
Yes, go ahead.
So almost all of the robot programming languages, the most important language that is programmed in a robot is by Teach Pendant, and British Automation of Robot Association claimed that over 90% of robots are programmed using this method. And over the years, robot teaching pendant has been changed in its design, but it basically looks like a giant handle calculator. So early pendants were large and large gray boxes with magnetic tape storages. Next slide. So the modern teach pendants resembles like a touchscreen tablet, and as the technology has developed to suit the ever-evolving users. To program the robot, the operator moves it in from a point to point using the buttons present on the pendant and move it around, and then they save at each particular position individually. When the whole program has been learned, the robot can play back the points at full speed. Next slide. So here are some advantages of teaching pendant. Most traditional industrial robots come with teach pendant, which makes them familiar to technicians, and this makes them technicians to handle the robot more easily. So the other point is that they allow precise positioning, as the robots can be programmed using numerical coordinates in either world coordinates, robot coordinates, or another coordinate system. Teach pendants are great for simple. I mean, they are best for simple moments such as painting in straight line or over a large flat surface. Next slide. And there are also some disadvantages of teaching Pendant. That is disruptive to the whole system due to robot downtime. Basically, robot downtime is nothing but the proportion of a time span that a system is unavailable or offline. So, yeah, the next thing is that the robot must be put into teach mode, and all operations must be stopped until it's been programmed. And it requires training to learn and program. And also, it might be difficult for craftsmen who are not familiar with programming. And now Ashish will continue to explain about the applications of teaching Pendant and its functions.
Hello, sir. Am I audible?
Yes, yes.
I am Ashish, and I will present applications and features of teaching Pendant. Here, I have listed down some applications of teaching Pendant. Uh, teach Pendant are used in industrial applications to program and control automated machines or robotics that perform demanding hazards and repetitive tasks. In next application, teach Pendant are portable control device that allow an operator to safely manipulate the action of robotic machinery. Next slide. Anurag, next slide. No. I think one slide you have moved. Previous slide. Yeah, this one. Next application. No. Next one. Okay. Teach pendants are designed to control the robot through a teach and repeated technique, where the operator uses the teach pendant to program the robot for a specific task, like range of motion or speed. And while a program is running, the teach pendant is the window into the robot's operation and where it is at in terms of overall program control. Yeah. Next slide. And here are some features of teaching pendants. The first feature, lead through program. Lead through programming is the only method that uses teach pendant to program the robot with position and functional data. This is important thing. Next, during lead through program, the operator work alongside the machine and uses the teach pendant to deliver data and process parameters. Next slide. Here is the next feature. The teach pendant enable integration of many components such as laser scanner, stack light, automated work handling device within a work cell. As a result, once the program is loaded on the robot, subroutines are written that coordinate the robot's movement with other activities in the work cell. So this I present. Next, I think Asad will present.
So I'll be talking about how to choose the best programming method. So recalling everything that was said before. So online programming is nothing but you'll generally stop the program or stop the functioning of the robot and turn it into programming mode, make changes to the program, and then you'll upload it. In the case of offline programming, you'll be so the program will be done first, and then it will be uploaded and the robot will start functioning. So keeping this in mind, so the first thing that you need to check is about the user. So the programming experience of the user will come as a first priority on how to choose the best programming method. So generally, if the programmer is a beginner, then it is better to choose one of the easier methods like the lead through programming in the case of online programming, or graphical programming method, which is a
offline programming method. So in the case of graphical programming method, we'll make use of simulation softwares, and in order to program the particular robot. So this is what. So this is the in the case of a user. So other thing will be to check the flexibility and compatibility of your programming method. So flexibility which means that how complex functions and programs can the robot handle, and how many things can you manipulate on the robot. So this is what we can say as flexibility. So this is one other thing that we must consider while actually choosing a programming method. So the next thing concerns with the actual programming method. So in that, the first thing would be the ease of programming. So ease of programming is similarly the learning curve of the programming method, and how many code lines you will be writing, and the memory. So in this case also we can, if we give highest priority to the ease of programming, so we can make use of graphical programming or hand guiding in the case of online. So next is the downtime. So already Anurag talked about downtime. So downtime is nothing but how much time the robot is actually not functioning. So as discussed before, offline programming has this ability to work on its own based on the program we have written first, and in case of any modifications we can write it separately and then download it. But in the case of online programming, the entire function should be stopped, and then it must actually be modified. So it is very apparent that in order to reduce downtime, it is better to make use of offline programming than online methods. So the next thing is the complexity of the program. So this is based on the complexity of the program. It is better to use the programming methods provided by the manufacturer. So at last, we'll go with sometimes it is better to actually physically plot the points or move the robot to plot the points and its path. So in this cases, hand guiding method, which is led through programming discussed before, will be the best way to go. So the next slide will be discussed by Anurag Jangir on the basic differences between online and offline programming.
Hello, sir. Am I audible?
Yes.
Yes, sir. Sir, good evening. Good morning. And yeah, so I am Anurag Zangid, and I am going to explain about the difference between the offline programming and online programming ISP. Yeah, so I had divided this difference into 6 parts: versatility, productivity, investment, rework difficulty, flexibility, and reliability of product uh, and quality. Yeah. So versatility for offline programming, so it is suitable for all types of chips, while in online programming it is applicable only in 2 cases. First one, chip support ISP, and second one, circuit board is designed for ISP with program pin access. And for productivity, for offline programming, I'm first considering programming speed. In offline programming speed is usually higher. In case of offline programming, as we have easy access to parallel interference of chips, and speed is faster with parallel data transmission, while in online programming, it is in serial programming, so its speed is quite less as compared to offline. And if we second point, if we discuss about concurrent programming, so in offline programming, superboard 3 is equipped with 32 sockets, so concurrent programming of 32 chips is easily possible in most cases. And if we talk about online programming, in congruent programming is decided by number of channels each ISP program supports. Size of PSP panel is also a limiting factor. With small size PSP, large panel can be supported Super Pro IS03 can support a panel of 16 PSP. Yeah. Next, uh, throughput. Sorry. So automatic programmers can operate at a throughput of 1600 units per hour UPH, while in online programming uh, it is it is not as high as automated programmers. Yeah, for other expenses, programming is an independent process and will not have any effect on testing cost. And in ISP, it is if programming is done on an ICT, then extra timing is needed for testing, which may involve additional operation cost also. And now I'm moving to next point of investment. So in offline programming, initial cost is higher, but we can recover it by programming require yeah. So the cost is easily recovered if chip programming requirement is very high. And while in online programming ISP, initial cost is low, and customer should consider cost of pogo pin replacement also if with cost of manual operation operator. And now I'm moving to next point of rework difficulty. So for various reasons such as incorrect data files, firmware upgrade and other factors, sometimes it is necessary to reprogram the chips. In case of offline programming, reworking is needed to desolder and solder the chips. And for ISP, no rework needed for data file changes and field upgradation. And now if we talk about flexibility, uh, change over time for one chip to different chip is it takes for couple of minutes. In case of automated programming, user need to install correct socket and ready to get after loading project files. And if in case of ISP, new programming algorithm developer and testing might be involved with chip part, number of PCB changes, and also there will be a need of designing new test fixer and different PCBs. And now I am moving to last point of differentiation, that is reliability of product and quality. So for offline programming, during programming, because of chip has to go in and out of the socket and feeders equipment, uh, so careless operations of automatic programming may result in chip pin deformation, resulting in degradation of solid soldering quality. So some of the aerospace, defense, and automotive electronics, medical electronics, and other high reliability equipments companies do not prefer offline programming. While for online programming is done after surface mounting, so no such risks are involved. So that's all.
Yes, very good, and it was a very nice presentation from you all people. And it was that you are keeping the timing also. It was very nice. And do you have any questions? Do you have any questions? Any queries? From my side, what was the difference between the lead through methods and textual robot language? Number one, and number two is what was the difference between powered lead through and manual lead through? And concerning the third point, and where we need the drawing with the aid of a robot, in which applications we are requiring drawings. Can anyone from this team? Can anyone? Anantakrishnan? From Anantakrishnan to Srish Babu.
I don't know the thinking.
Yes. Anyway, think in the line and get a find answer for this. And Akilan and Amula Srikanth. Akilan and Amula Srikanth.
Sir,
Yes, Ashish.
sir, Akilan told that he has gone to a hospital right now.
Okay.
Can we have his tomorrow, sir?
Yes. What happened to Amula Srikanth?
Not sure.
Yes, sir.
He'll be here. Yeah, he's here.
Good afternoon, sir.
Yes, Amula Srikanth. Are you ready to present your content?
Yes, sir.
Yes, go ahead, Amula Srikanth.
Good morning to everyone. Today I am going to discuss with you about floating based kinematics. Okay, we will start our discussion with an assumption that we have n degrees of freedom. So let us say we have P active joints and L passive joints. As we know that the degrees of freedom should be equal to the sum of the active joints and passive joints. So we will get the equation that L equal to n minus P. So from this we have to write a configuration vector Q. So it is written here. Here QA and XP are
Give
QA,
FI. Give FI. And continue.
QA is the joint configuration and XP is the position and orientation of the coordinate systems. Additionally, the robot may be in a rigid contact with the environment. For example, a standard humanoid with 2 feet on the floor. To represent such contact, we write that the robot has k linearly dependent constraints at a position or orientation in the vector image vector as xc. By definition, these constraints undergo zero acceleration with respect to the inertial plane, and we write the condition as shown Jacobian constraint. Yes, sir, that's it.
Okay, that's it from your end. Amala Srikanth. That's all about it. Okay, fine.
Yes.
Okay, we'll request Agilan to present in the subsequent class. Okay, dear representative, it is feasible to continue today's session as per our said schedule. We'll continue to 12:30 to tomorrow. It is okay for you, or else will as per your representative suggestion, we can take the session during Friday 9:30, which will be suitable for you to go present. And concerning the first batch, I requested Abhishek Shakuria to consolidate. Abhishek Shakuria, please consolidate and send the content. And concerning the second batch, Anantakrishnan, Anantakrishnan, you consolidate the slides and you upload in the MS Team. That your friends also can. Yes.
So I've sent it to you in a direct message, all the slides which we did right now.
Yes, sure. Okay. The third team, I think third team ready. And okay, anyway, you share your convenience to your representative KD Singh as well, Chitash. Chitash and KD Singh will make communication to myself, and through that we can have a class either on tomorrow 12:30 or by Friday first hour. Okay, thank you.
Friday we can
Yes, what? Yes.
Yes, sir. Tomorrow's class we can compensate on Friday, sir.
Friday. Okay, fine. For both the classes, the timing is okay.
Yes, sir.
Okay, fine. Okay, we'll meet during Friday 9:30. Thank you, Ananda.